Alright, welcome back to part 3 of the Let's Trick Out a 128. And this little box, let's see, is the GG Labs RGBI to VGA adapter. So, it's got, regular 9-pin on one side and the 15-pin on the other. This has to go through one of those, the GBS 8200 VGA adapters that'll give the right sync for modern monitors. I believe if you have an old multi-sync monitor, you may not need to do that. But I don't have a cool monitor. All I got are beater junky ones, so we'll take this, get the output to basically what's VGA-ish. We'll feed it through the GBS to get the sync, and that will actually drive the monitor. So this board was, I think I mentioned, was from GG Labs. Seems well made, and I have high hopes it'll work just fine. I printed it didn't come with the case. This is just something I printed out off Thingiverse. It was a freebie download. Don't forget to tip your modelers. But yeah, that ought to be a good thing. And then this other package came all the way from our friends in the north, the ClearVideo128. This is a modulator replacement. Should be a fairly straightforward install. Might be a little fiddly to get everything lined up the way we need to on the back of the case, but I think we can make do. And might have to do one little tweak to this thing. We'll talk a little more about it later, but this itty-bitty little cap right there, C13, might need to be replaced. This is the C model. This will give you composite output as well as S-video. The composite will come through the original DIN jack. But the guy who built these, Jason, super cool dude. He wrote me a quick little note the other day, even before it arrived in the mail, saying that he believes he had a run of these boards where he put the wrong cap in there, and that might make the composite video look a little blurry or washed out or something. So he offered to just outright return the board for me or send me parts or anything, but I told him, nah, we got parts and a soldering iron, no point in shipping anything. We'll make this thing go. But super, super cool guy to reach out like that, and much appreciate the work he put into this. And hopefully it'll clean up all the nasty jail bars that come out of this machine. So with that, we'll get this machine torn back down, rip the board out of it, and let's see if we can get the old modulator out. All right, we got the board out, the tools warmed up. We'll reflow some of these joints here on the modulator with some of this chip quick stuff. It seems to much help the desoldering process. So yeah, it looks like there's the 4 big ones from the can, and then the 8 pins, just like on the 64, for your signals in and out of the modulator. Hopefully they come out just as easily as the luck I've had on the 64s that I've done. And with the right tools, it's really pretty easy. Just got to be a little patient and don't force anything. I'll use my favorite tool ever, the Hakko desoldering iron. Love this thing. Alright. So in theory, I believe this should be free-ish. We'll see if it wiggles at all. A little wiggle out of them, but I do not want to tear up any of these traces. Alright, we'll get the hot air gun going. Alright, the hot air is all warmed up. I got the board kind of stood off from the desk. I just have a cartridge sitting under it. That'll give me enough room to work. And it looks like all our metal tabs are free. I was able to get the tool in there. And we'll just heat up all the pads from the little pins here. They look clean. I don't see any solder left in there, but you never know what's on the other side of the board. And I want to make sure we don't break anything doing this. Pretty good. And that's the last guy that's holding us up. Yeah, this isn't a heat thing. He's clearly loose from the board. He's wiggling around in there real good. There we go. One warm modulator out of the board. Maybe we'll crack into him later and play with him, but I don't think it'll ever go back in the machine. Everything looks good. No damage, no lifted traces, just a little bit of funk to clean up. And yeah, it looks real clean on that side. Alright. Give him a little alcohol bath. Alrighty. Alright, now we'll break out the new toys and figure out what we need to do to get this bad boy installed. Alright, I've done some prep work and we are back. So, this board does need power, so tacked on the included power wires, and that's going to go over to I don't know, somewhere to ground and off the cap here where the unregulated 9 volts comes into the board. I'm sorry, it's I think it's unregulated, but it's rectified. I don't think it actually goes through regulator because there is a little regulator on here it goes into first, but it is rectified 9 volts DC, but unregulated. So there's 2 lines for AEC and PHCL. PHCL is a new one. I mean, I remember AEC from the noise on the VIC in the 64. Not sure what PHCL is, but it's probably some other interfering line, and this is where you get the reference from that line, so the inverter here can generate the opposite signal to cancel it out, right? So those 2 are going to get tacked down to the motherboard pad here and somewhere else around there. It's in the documentation, came with it. By the way, Jason wrote awesome documentation for this, and I read through it a couple of times. It's extraordinarily detailed. And I decided, hell, we'll just wing it. So what I found is that for this board to sit in there and get lined up with everything, this corner of the board basically needs to be touching the motherboard. It's got to be way down there, and then you get your pins all in line. And when looking on the bottom of the board, the pins... Well, let's see if we can get this guy started. Yeah, so the pins all the way over here are going to be pushed through damn near all the way. They're going to be hanging way out. We'll solder them on and then trim them. This pin needs to just barely be protruding through. And they'll all be, uniformly getting taller as it goes there because the whole board's, canted sitting on an angle. That seemed to be the best alignment into the back of the case. So I'm gonna get some soldering stuff warmed up here, and we'll get this guy tacked in place and test him in the case. All right, everything's warmed up, so I think we can start tacking this thing together. If you notice, there's one little square pin header in here, and these are all square pin, not round pin. And I got some heatsink junk on them, but yeah, all these connections are square pin. These are a lot tougher than the round pin headers, and they fit perfectly fine in these holes. So we're using the square pins to make this thing a bit stronger. So it came with these 8, and he also threw in some additional post. Basically, I don't know. This is some kind of board-mounted plug, but in his directions, you use these as the mounting pins, which we are going to use some of those. I happen to have a bunch of the square pin stuff laying around. I use it for all kinds of junk. So I when I test fit this board, I tacked him very, very loosely into the ClearVideo board, and that way I was able to to help get this thing lined up where it needed to be. Then I just heated up this side of the pin and got it out. But we left him in there after our little test fit. And let's see if we can get all this stuff to line up back in. There we go. He's on. Alright, so we're through everywhere. And, you know, if you don't care about these rear ports and you're just going to use the DIN, kind of doesn't matter where this thing lays. I think this is an awesome feature, though, and definitely want to use these. So what I found was, when I had it in there, you know, it was all the way down against the center pin that I put in, and then canted all the way to the right-hand side of the board. And that seemed to be the sweet spot for clearing everything on the back of the case. And then I brought it back just a hair. I don't know how well this is going to come out. Let's zoom in. So if you see the pins on the right-hand side of the board, they're going to be sticking way out like that. And then on the left-hand side of the board, I brought it in so that the very far pin was just barely coming through the via there, so we can get a little ball of solder on it. Like, that would be too far. You want it as far as you can go, because that's what's going to get everything to line up. So you want it just barely poking out of that last hole. And then we will precariously balance this on my hand, drape some solder over here, and see if we can get it tacked down without moving around anywhere. There we go. We got him in there. Alright, so we got one pin holding there. Did it in time before I melted the wire. Before you go and put all the joints in place, definitely makes sense to test fit this many, many times, because it's not exactly a drop-in fit. And tolerances in motherboards and cases being what they are, everybody might be a little different, but it ought to be pretty close to what I just did. This is a little fiddly, but in the grand scheme of things, I think this is going to be awesome and worth it. There we go. That's where he needs to be. Alright, so he's still attached. These guys are way down there. We got our sound jack. Let's get this motherboard up in there. So our sound jack is lined up. Our S-Video jack is lined up pretty good. Our board is about where the board should be. You can put a couple of screws in the motherboard, kind of hold it in, make it a little bit more accurate of a measurement, but I think I'll just hold down on this a little bit, heat up the solder on this pin here. We'll try to do this without melting our case. There we go. Now he's tacked down where he needs to go. And the case is no worse for wear. Now it slides in and out of there just like it should. So I'm thinking I'm pretty satisfied with that fit. It doesn't get any better than that. You know, it looks like it's on an angle on the inside, but so what? This thing is going to be awesome when it's done. You know, for nothing else, just having the S-Video jack on the back, but if we can even get the jail bars to be half of as bad as they are now, I will be a very, very happy camper. Alright, so now, I think on the bottom we just need to, yeah, we are all connected there. We just need to finish soldering these guys in and trim these pins off. Because they stick out quite a bit farther than anything else on the bottom of the board, so we will definitely have to trim that up so everything fits just right. I think it was clear on the bottom of the case, but if you especially if you're going to put the heat shield back on this thing, or the RF shield, I should say. It would definitely make sense to trim those guys off, or they're going to cause you all kinds of problems when they short out against that shield. And these pins you want to make sure are soldered very well, because they are partly responsible for holding everything together, and all the video signals run through it. So you want to make sure these are very, very good and clean connections. So I'm going to go back over them all a second time. I want the video on this thing to be as good as it could possibly be. Alright, where's our cutties? And these things are going to go rocketing across the room when we cut them. Alright, not too bad. And of course we want to clean all the flux off of here. It could be mildly conductive. And for most signals it wouldn't matter, but for a signal you're going to see, and we're trying to get as clean as possible, we definitely want to clean all this junk off of here. And it's just a good idea for good housekeeping anyway. We've got our one big blobby pin in the middle, kind of holding things together for us right now. Alright, we are looking good. We gotta... should have cleaned the top of this. That is good enough for now. Probably give it the royal treatment with some Q-tips or something by the time's all said and done. But I think that's a winner right there. And so we do have our pin here, our 8 pins on the back, but we also have 2 holes here as well. And that's what these enclosed extra pins are for. Just to kind of act as a little structure for either side of the board there, give it, you know, better connection to ground as well, and some physical stability inside of there. So we're going to pull this out of the little plastic deal here. So we've got a pin. These should fit right through. Very nice, very nice. So we can come straight through the bottom of the board, through the ClearVideo, and I think that's about where we want it. It's definitely in there supporting the board. I'm going to come through, I think at an angle this way, because there's a whole lot of solder pad down around the side. So I'm going to come through at an angle there so we can tack it into that corner. That'll give it the most structure we can. And I think that ought to help hold this thing all together. So yeah, I think we're pretty good there now. Alright, that thing is solid, man. He ain't going anywhere. Pick up the whole board by it. Not bad, not bad. Alright, let's get the cutties. I need bigger cutters for this, but cut off the extra here. I left a little bit extra hanging out. Think of it like the service loop. You never know if you gotta re-angle the board a little bit just to have a little bit of extra something to work with. And there we go. That thing is absolutely solid. Let's see, how do we want to do this? Take him, go around and inside. So now he's laying right inside there. A little bit of heat. Yep, he is in there. And then for the negative side, we'll go to the negative side of the cap. And we should be good to go. Got the wrong one. A little more. There we go. Alright, nice. So we got video, we got power, now we need our signals to invert. So on this side, the shield, let's move this over, the shield is actually tacked into the ground side of the pads here. There's, it's like a typical 2.5mm offset thing, right? The positive for each of these signals is on top, and there's a ground right below it. Going into the board, I think we're going to wind up just snipping the ground off. And it's really just shield anyway. We're only carrying a signal. Everything's grounded anyway. So this is really acting more like a shield than the negative of a circuit, if you want to think about it like that, right? So looking at the picture, the AEC line, this one, he goes around to a pad right next to R21 next to this 4066. So that pad right there is where we want to tack this side of the connection. We come around like that, and I think we'll be in good shape. So we're going to cut off all this extra braid. We don't need it. Make sure you get all the little straggly hairs off of there too. You don't want that junk shorting something out, because it is grounded on the other side. And we might even do, just to be on the safe side, because I don't like extra little metal shavings around, we're going to throw some heat shrink tube over him. Alright, so look at the dock again. AEC goes down to R21, or the pad right next to R21, I should say. Splash a little solder on him. And a little solder on him. trim him down quite a bit. So we just need the tiniest little bit to sit on that pad. Yep, he's on there good. All right, we have R48, little pad next to him, a second pad further up, and it will go into the one right above that. So that's going to go into that pad. I'll get my fat thumb out of the way. That pad right there. Alright, so the close one, far one, second far one. Yep. Alright. Close one, far one, second far one. This one too, we can come around a little sideways. Probably should have done this one first. All right. Got our wire installed. Might need to use a zip tie for a little bit of wire management later. But that'll work for now. All right, let me get a power supply, some wires. We'll plug this bad boy in and see if it still works. Alright, I think we're all rigged up and ready to go. So the tuning directions aren't 100% clear. It's I was hoping for a little more guidance, but we'll figure it out. It said turn all the pots clockwise until there's no discernible difference in the video, and then start turning them counterclockwise until you get a ballpark good setting. I wondered if there was a particular order to tune them in, but I guess we'll just work our way down the row of pots and see how we do. So let's see. All right, it still works, and the jail bars are worse than ever, as I'd expect, because this thing is not tuned at all. So we're going to turn all these clockwise. And I gave them a good couple of turns before I even started, but I don't see much of anything going on. Alright, so I twisted on all those tuning screws for days and days. I had to walk away from it for a while. It's I think it's like 3 weeks or even a month later at this point, and I'm finally getting around to wrapping things up. But I tuned and retuned. I finally got it as good as it's going to get. The jail bars on the 128 are just infinitely worse than even the worst of the 64s, I think. There's just a lot more going on in the VIC, and that's where all the noise comes from. There's only so much you can do to it. There's really no cure-all for jail bars without doing something drastic like doing an RGB conversion or something like that. So, and those things are possible, but I don't want to go all the way that deep into it. This is definitely workable and doable. The bars are still kind of visible. If you're playing a game, you notice them less for the most part, but I still absolutely recommend the ClearVideo128 mod for these things if you're going to use 40 column mode at all. But you're never going to get it 100% crystal clear no matter what you do on any of these 80s machines, really. But huge improvement. Happy I did it. Definitely a good thing. So moving on from 40 column mode, I acquired this TV for about 15 bucks. I like it because two things. One, it has an S-video input as well as a VGA input. and the other one is it's dual voltage. It'll run 100 volt to 240 volt, 50, 60 hertz. So it doesn't have some restrictions like that. But at any rate, we kick it over to 80 column mode, send it a reset, and this looks pretty good too. So some of the letters might look a little weird, like the pixels are squished here and there. You can play with all the different width settings, horizontal and vertical, and stretch it and move it around and whatever else. But this was good enough for me. Here we'll come a little closer. So we have our GG Labs scan converter, I guess, if you want to call that thing, RGBI converter. That goes into the GBS 8200. He's plugging in the 31 kilohertz sync so that it'll work on pretty much any monitor known to man. All in all, pretty happy with the way it looks. I'd love to get an RGB to HDMI kind of thing for it, but I think those CPLDs are still in pretty short supply. But definitely workable, happy with it. I've used it to log into routers and work on stuff. I'm a network dude, so this thing actually has a real purpose for me when I put a Wi-Fi modem on it. All right, we'll cut here. We'll do one more shot of the inside and call it good. All right, so here's the final recap and everything done in all its glory. But we've come a long way. Power switch, couple of RAM chips that we did in the earlier videos. The ClearVideo, the install was really not nearly as bad as I thought it was going to be on that. That worked out really well. These little pads here, they wound up actually being through-hole vias, so I was able to get those little coax wires directly into the board instead of just onto the board, and they hold in there quite well. S-video and audio out on the back is kind of awesome. You don't have to use the DIN cable, just good old off-the-shelfers. All our ROM stuff going on over there, and I decided that we needed a cooling fan as well. I had this out of a Raspberry Pi kit that I didn't use. It's a 40 mil fan, a standard fan, and it turned out 4 of the vent holes in here lined up perfectly. We just had to drill them out a little bit to get the screws through there. So now we have a little forced air going into that can, and it dramatically dropped the temperature of that stuff. So I'm real happy with that. Heat sinks everywhere, Arduino to do our little switchy over there, and I'd say this thing's done. So we'll put all the screws back in them, close them up, and play some video games, log on to BBS or something. But this has been a fun project. I think everybody should get their hands on a 128 and trick them out. Definitely a unique and misunderstood machine, and I'm glad I took the time to get to know it. It's when I was a kid, kind of half wrote them off as a joke. Every one you turned on, you just typed Go 64 on it. But knowing more and more about this machine and what it's capable of, they're definitely unique, and I'd say function wise, they're king of the 8-bit heap. They've got a lot of stuff they can do. So anyway, take care all. Hope you enjoyed some of this. Hope somebody may have learned something. And comment away. Tear me up. Let me know what you think. Thanks all.